Hello, this is the luckiest maths teacher in the world. Today we'll look at constructing as well as adding and subtracting matrices. So first we'll look at constructing matrices. So you saw last time a matrix, and we usually denote with a letter like A, is just a rectangular array of numbers. So let's say something like this. Okay. Now, each of these individual numbers is called an entry or an element. So we have a special way of identifying elements. So what we do is we write the letter of the matrix and we write like an I, J down the bottom in subscript. So I refers to the row number. We always write rows first, as we did when we were writing the order of a matrix, and J represents the column number. So this here allows us to find the entry at any point in the matrix. So for example, element A11 is the entry in matrix A that's in row 1, column 1. So that's just one. Let's say 23 is the element that's in row 2, column 3. So A23 in this case is 6. If I wanted to try and find A32, that doesn't work, because that would be the entry in row 3, but there are not 3 rows in this matrix. So that's how we refer to elements. So now we're going to look a bit more about constructing matrices. So often matrices start from tables. So I'll show you that in a second. Please pause and copy down if you need this. So you're all familiar with table, and we saw some of these in, say, financial mathematics. So let's say I have a shop, and yes, you guessed it, I'm going to sell colognes. Now let's say that I have a couple of types of colognes. So I've got my favorite brands. I've got my Creed, I've got my Tom Ford colognes, and another brand called Mansera. And let's say I want to know how many men's colognes I have and women's colognes. So you've seen tables like this before. And I can just populate them with random numbers. Of course, in this case, all of the numbers will be whole numbers, positive whole numbers, because we're talking about the number of something. So I can put this into a matrix. So this matrix, just like the table, it will have 1, 2, 3 rows and 2 columns. 7, 5, 8, 6, 4, 7. So that's very easy. It's almost commonsensical. All we're doing is basically taking the numbers from a table, and we're not having these headings here. Because what we want to do is we want to eventually add and subtract these matrices. We can't subtract, the word Creed from the word Tom Ford. That doesn't make sense. So we're just putting a table into a matrix by putting all of the elements, all of the numbers in the table, into a matrix exactly the same as it was in the table. All right, so now we're going to look at adding and subtracting. Again, pause and copy down if you need this. Okay, so to add and subtract 2 matrices, the matrices must be the exact same size. So that means they have the exact same number of rows and the exact same number of columns. Matrices must be exactly the same size. So that doesn't mean that they have the same number of elements. So for example, let's say A equals a 2 by 2 matrix, 1, 0, 0, 5. And let's say B, I'm going to make it a column matrix, 1 column. It's 0, 1, minus 1, minus 2. Now, even though A and B have the same number of elements, A is a 2 by 2, B is a 4 by 1. So they are not the same size matrix. So I could not add these together. So if I have a matrix C, I'm going to make it a 2 by 2 as well. So let's say it was minus 3, 5, 8, 1. So I could add together A and C because they are the same size. But I can't add either of them to B. So how do I actually do it? Well, it's actually pretty simple. If I want to add A and C, what I do is I line up the 2 matrices and I just add corresponding elements. So that's sort of why I went through how to identify elements before. So this is A11, element A11, so I need to match it up with element C11. So I'll just write that down. That's the entry in row 1, column 1 of A, and this is the entry in row 1, column 1 of C. So I add those two together, and that's the entry that goes in row 1, column 1 of the resulting matrix. So I would have 1 plus negative 3 that goes in here. Now, as you probably know, 1 plus negative 3 is, of course, just negative 2. So then I just put a negative 2 there. So I do the same. The entry that goes here is going to be A1, 2. So the entry in row 1, column 2, plus the entry in row 1, column 2 of matrix C. Sorry, there should have been a plus between them. So 0 plus 5, of course, gives me 5. Then 0 plus 8 gives me 8. And then 5 plus 1 gives me 6. So the resulting matrix, when you add them together, is always the exact same size. So we can't add two matrices together unless they're the same size, and when we do add them together, the resulting matrix is the same size. So let's just look at a subtraction. So let's define, say, a matrix D, and I'll just make it a column matrix, so 3 minus 2, 1, and I'll define matrix F as minus 1, 1, 3. For example. So both of these matrices are the same size. They have 3 rows and 1 column, so I can add or subtract them. Now if I'm doing subtraction, it's almost the same as addition, except rather than adding each corresponding element, I subtract them. So D minus F will be 3 minus minus 1, so this minus this, then of course minus 2 minus 1 and 1 minus 3. So you're just subtracting the corresponding elements. So you get 4 minus 3 minus 2 in this situation. And we note that our resulting matrix is 3 rows by 1 column, and it's the exact same size as the original 2. So now we're just going to look at an example where we're finding one or more of the elements. So let's try a question like this. We're already given the resulting matrix, and we need to use that to find a couple of elements. So we know from the way that matrices are added that we add corresponding elements. So the one in row 1, column 1, plus the one in the second one, row 1, column 1, equals that. So I know that x plus negative 7 equals 10. I also know that row 1, column 2 plus the one in row 1, column 2 equals the final number in row 1, column 2. So 3 plus 2y equals 11. So these equations are pretty easy to solve. So if x plus negative 7 equals 10, all you need to do to undo the subtracting 7 is add 7 to both sides. So x would be 17. In the second one, 3 plus 2y is 11. So I subtract 3 from both sides and then divide by 2, just like I would for normal numbers. So y would be 4, x would be 17. How easy was that? I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Thank you for watching.